And we're back and better than ever in 18-2, where we are now going to use our KEQ, our equilibrium constant, to determine an unknown concentration. So let's look at example number 5. Consider the same reaction as in example number 4, and that was the Haber process where you're taking nitrogen and hydrogen to form ammonia. Calculate the ammonia concentration if the nitrogen is 0.5 molar and the hydrogen is 0.25 molar at equilibrium. So let's go ahead and revisit our KEQ, our equilibrium expression. KEQ is going to equal the ammonia squared divided by the nitrogen and divided by the hydrogen cubed. Alright, so all we need to do is first plug in the values and then solve for our unknown. Our KEQ we have as, we'll just use the average, 0.0602. That's going to equal our ammonia concentration. That's what our unknown is. That's what the question is asking us to solve for. Squared divided by the nitrogen, which is 0.500 molar, raised to the first power, and then the hydrogen is 0.250 molar, and that is cubed. Alright, now let's go ahead and isolate our variable here. So we're going to multiply both sides by 0.500. That's going to divide out the 0.500 on that side. We also want to multiply both sides by our 0.250 cubed. So we'll have 0.250 cubed. That's going to divide out that term on this side. And now what we're left with, let me go ahead and move down just a little bit here. What we now have is the ammonia concentration squared equaling, and if we evaluate this whole term here, what we get is 4.7031 times 10 to the negative fourth power. Alright, so that's where we're at so far. Now, is this the concentration of the ammonia? No, the ammonia right now is squared, so we're going to have to undo that square. Now, many of you already know that you can take the square root of this, but another way that you can do this is by raising this thing to the fraction, the inverse power. So let me scroll up here. We got a little bit of room. Let me review a few things here. If you have x squared equaling, say, 4, alright, one way that you can evaluate this is to take the square root of it, of both sides. That would be fine, and of course x would equal 2. Another way that you could solve if x squared equals 4 is to raise both sides to the 1/2 power. Alright, and so this 1/2 and this 2 would divide or multiply out, and you'd be left with x equals 4 to the 1/2 power. And if you type that into your calculator, the 1/2 power is exactly the same as the square root. Or if we have, say, x cubed equaling 27, this of course will equal 2 here. If you have x cubed equaling 27, you can take the cubed root of both sides. That's one way to solve that, and of course that would equal 9. Or if you have x cubed equaling 27, you can raise both sides to by the 1/3 power. Either way is fine. However you learned it in math is perfectly acceptable. So the bottom line is if you have x to some power n equaling y, whatever it is, you can either raise it, or you can take the nth root of both sides, or you can raise both sides to the 1/n power. And if you need help with that, please see me in class, and I'll be happy to go over that a little bit more detail. All right, so where were we? Scrolling down here, we're with the square root of the ammonia concentration is equaling this value over here, the 4.7031 times 10 to the negative 4. So what I'm going to do is I'm going to raise both sides to the 1/2 power. Okay? And so now I have the ammonia concentration equaling, and if you take the square root of this side or raise it to the 1/2 power, you do get 0.0217, and we're dealing with the concentration of the ammonia here, so we can label this molar. So this would be the concentration of the ammonia if this is the equilibrium nitrogen and this is the equilibrium hydrogen. Now here's the cool thing. You can double check your work and make sure that you're correct every time. Because you know that KEQ has to equal 0.0602 in our case, what you can do is say KEQ is going to equal, and now plug in all of our values back into our equilibrium expression. So our our ammonia, we just solved as being 0.0217. We have to square that. Our nitrogen is 0.500 molar. That's raised to the first power. And our hydrogen is 0.250 molar, and we're going to cube that. And if you solve or evaluate that term, what you get is 0.06027 for our KEQ. Well, we calculated our KEQ to be 0.0602, so we're right there. So our answer makes sense and is in agreement with what we've already found. All right. Now what you can do is you can go ahead and work through example number 6 and example number 7 on your own, and in the next podcast we'll show you how to solve those. We'll see you next time.